then TERHORST-NORTH, who is our first speaker or keynote speaker for the conference. So the joy of coding, enjoy the talk.
Hello, thank you. Good morning, good afternoon, good very early morning, depending where you are. I know there was at least one fellow speaker, Randy Schaup, yesterday tweeted that he was going to be up at 4 a.m. To listen to this. So I hope, Randy, I hope this is worth it. I too am really sad I'm not in Budapest. Craft is a really special conference for me. I think I've been at every single craft so far except for one that I couldn't make. So I wasn't going to miss this one. Welcome everybody. Thanks sponsors again for making this possible in this crazy world we're living in right now. So I'd like to talk a bit about coding. I don't think we talk about coding enough. We talk about code a lot. I don't think we talk about coding enough. So I was challenged recently what I think makes good software. And there's a bit of a backstory. I'll tell you the backstory. And I was thinking about this from a human perspective, from a developer's perspective. So let's take a look then at what some of this might be. This started again by accident. A lot of the work I do starts by accident. Behavior-driven development started by accident. This CUPID has started by accident. What happened was about 4 years ago now, 2017. I was speaking at a conference called PubConf. Now, PubConf is a brilliant idea by a chap called Dylan Beatty. And what he does is there's another global conference. Well, it started in Oslo, now it's in London, and it's around the place called NDC. And NDC, big conference, quite expensive. So what Dylan wanted to do was create a little after-party conference for people who either couldn't go or couldn't afford tickets. And so the idea with PubConf is very simple. It takes place in a pub. He grabs a load of speakers from the event, and they all give a 5-minute lightning talk, and it's like an Ignite style talk. So the slides auto forward every 15 seconds. You have 20 slides, 5 minutes, and that's it. And then there is a very simplistic voting system which involves yelling and cheering and stamping, and whoever gets the most yelling and cheering and stamping wins. So I was invited to speak at a PubConf. Well, the other thing that you should know is that PubConf is never recorded. What happens at PubConf stays at PubConf. So I was invited to speak at PubConf, and for some reason, I think recently I've been talking about Solid or thinking about Solid, which is Solid is an acronym for a set of 5 principles, software development principles that Robert Martin thinks are very key. And Mike Feathers noticed that if you wrote them in a slightly different order, you could spell the word solid with the first letters. So things like single responsibility, Liskov substitutability. And I was looking at these and I was doing some head scratching because, I mean, they're great, right? They're fine, but they don't particularly help me write better software. I don't think of solid principles when I'm writing software. And so I decided as a tongue-in-cheek thing, as a joke thing, I was going to write a talk called Why Every Single Element of Solid is Wrong. And the motivation for this is because I'm lazy, right? So what I wanted was a talk that would write itself. So I figured there's 5 elements of Solid. If I do one slide to introduce the idea, introduce the element, the principle, one slide to say why I don't like it, and another slide to say what I do instead, that's 15 slides. If I top and tail it, that's my 20 slides, I'm done. So basically the talk kind of wrote itself. So I did this talk and it was fun and lots of people enjoyed it. And then I thought no more about it and I put the slides online. And as soon as I put the slides online, the software craftsman people came for me with pitchforks. They got very cross that I dared to challenge the holy writing of Solid. So we had some fun banter on Twitter for a while, and that was the end of it until the beginning of this year, when a lovely chap called Phil Nash, who's one of the occasional organizers of Extreme Tuesday Club in London. And Extreme Tuesday Club is the oldest, I believe, XP meetup event. It's been going since about 2001. It happens in a pub in London, except for nowadays, obviously, it happens online. and their topic was going to be solid. And Phil said, "Hey Dan, why don't you come along and talk about solid?" And that talk you gave, so I thought that'd be fun. Let's do that. So I did, and he said, "Right, I know you're going to bash solid. I know you're not a fan. What would you put instead?" Which I just thought was a fantastic challenge. He said, if we're not going to use solid anymore, what would you replace it with? And the broader question was like, is there anything you could replace it with? Are there characteristics of software that are universal? Are there any universal characteristics? Which was a great question. So I kind of took that challenge. And I came up with deliberately 5 that spelt something. So the word I chose was Cupid, because this was in February and we'd just had Valentine's Day. So I made mine spell Cupid. And I decided it's going to be kind of, the opposite of solid is hard and all of that. And Cupid is kind of fluffy and loving. So I thought we'd go with Cupid. And then I had to write it up because then conferences happen. And so my plan was never to poke at solid, except that some folks asked me to give a talk. And then my plan was never to come up with Cupid, except some folks challenged me. And then my plan was never to write it up, because I'm super lazy. And then a couple of conferences, including Craft, said, "Look, come along and talk about this thing." So now I've had to do work. So I figure I should tell you where Cupid came from and why I think it's valuable. So let's take a look then. Who are we writing code for? Let's think about the people involved in this. One of my favorite quotes is from Martin Fowler. It's from his 1996 book, Refactoring. So this has been around a while, 25 years. Wow. He says, "Any fool can write code that a computer can understand. Good programmers write code that humans can understand." And I just thought that really landed for me, right? When you look at code that was written for another human to understand, that's a big deal. And then I was reading this and I thought, understand, can we do better than understand? Understand's not a very high bar. And then a while back, a chap called Kevlin Henney introduced me to a quote. So I'm dropping lots of names here because loads of people, I've got lots of influences and lots of people have shaped my thinking. So Kevlin was giving a talk, I believe at a Craft event actually. And he introduced this lovely quote, again from the 90s, by Dick Gabriel. So Dick Gabriel's a kind of a pillar, if you like, of the software world. He's very early kind of Lisp influencer. He's been around a long time and he's had some very great software thoughts. And he was talking about this idea of habitability. And habitability is a great word. Habitability is the characteristic of source code that enables, and then he listed a bunch of different types of people, enables people to understand its construction and intentions and to change it comfortably and confidently. And those are really important adverbs, comfortably and confidently. How often, when you're changing someone else's code, are you comfortable and confident? I'm going to say, having worked with a lot of code over several decades, and most of it wasn't mine, not very comfortable and not very confident. And then he says this lovely phrase. He says, "Habitability makes a place livable, like home." And I just thought that was a beautiful idea, a beautiful kind of concept. And I thought, well, okay, that's great. But now, so habitability is cool. Habitable sounds better. What about joyful? What about code that makes you smile, that warms you inside, that you go, I'm going to really enjoy working on this? Think about, and I don't know where you are in your software careers. I don't know how many systems you've worked on, how many code bases you've worked on. See if you can think of a code base that's joyful to work with. Have you had that wonderful experience where you work on a code base and it brings you joy? And what was it? Right? What was it? Can we describe what makes code joyful? Can we describe what made that code base joyful? And if we could, what kind of properties would joyful code have? And I'm using the word properties very deliberately. Okay. And deliberately in contrast with principles. Again, the solid canon, and there's a whole bunch of these principles. It's just the first 5 spell this acronym. The solid canon is all about principles. And for me, I'm not a fan of principles. Principles sounds like rules or heuristics. And the problem with rules or heuristics is they define a boundary, right? You're compliant or you're not compliant. And I heard, because again, I've been talking about this in the world and on Twitter and things. And so I'm getting lots of inbound signal. People are sort of talking to me and sending me stories and anecdotes, and one that comes up again and again is of the junior engineer. They've just finished college, you know, they're fresh out of school or whatever, into their first job. They have that wonderful confidence of the young and not yet disillusioned. And what they would do is they would look at this code base. They come into their first job, look at this code base, and they say, that code is violating SRP. That code is violating Liskov substitutability. That code is, and they just go around with basically like with these chits, and they're handing out these violations. And it's just heartbreaking. Like, hang on a minute. This is so programming is a collaboration. It's a team effort, right? And so if you go around knocking other people's work, that's not a good way to make friends. But also that person is doing what they know. That's what they've been taught, right? They've been taught that code either is good code, or it's solid code, or it's violating these principles. So you either conform to the condition or your code is wrong. And I'm not a fan of that kind of framing. So properties are qualities or characteristics. So they define a center. And there's some lovely work about kind of centered versus bounded communities. And centered communities, you have a principle or a property that you move towards, like kindness or something, and you can be more or less that thing. Okay. Now, you're never away. You're never outside, right? You're just further or nearer to the center. And there's always progress you can make towards the center. And that to me sounds much more human and much more engaging. So your code is only ever closer to or further from the center. So that's why I went with properties or characteristics. So I want to be able to describe code that is joyful to work with. And then I thought, well, can we get a bit meta here? What properties would properties have? If they're going to be properties that I think are universal, what properties should they have? And there are three. The first thing is they need to be practical. They need to be applicable. They need to be easy to describe, right? To articulate, easy to assess. Is my stuff, how close is my stuff to this thing? And could I move it towards this thing? And easy to adopt. So I'm going to assume that the code base I'm working on isn't very CUPID. It doesn't have much of the CUPID properties about it. What can I do about that? So that's the first thing. It has to be actionable. The second thing is it needs to be human-centered, right? And again, if we look at the solid principles, they're code-centric. They tell you about the code, the structure of code, how the code, what the code is and does. I'm looking at this from a programmer perspective. What's the code like to work with? Okay. And the third thing is I want it to be layered. It's not just a simplistic black and white, this is a thing. It has nuance, it has layers. So as a beginner, when you're first coming to this stuff, you go, oh, okay, let's take a look at some of these properties. Yes, I can immediately understand what they're about. When you've been around software for longer, and you've been around software products for longer and software teams for longer, then you can start to have more kind of nuanced discussions about these things. That's what I wanted as well. Right, so that's enough backstory. Let's do the reveal. So CUPID for joyful coding. There are 5 properties, characteristics of code that I think makes it joyful. I'm going to tell you what they are, and then I'm going to kind of drill into each one a little bit. So C, composable. Okay, composable code is joyful. Composable code is code that plays well with others. Unix philosophy. So the Unix philosophy is this, is that that anything should do one job and do it well. It should only do one job and it should do that job well, which I'm a fan of. Unix philosophy is also about composability. So you'll see there's a lot of interconnectedness of these things. Predictable. So predictable, the code does what you expect. And again, there are many, many layers to predictable we can look at. I'm going to start peeling some of those layers today. And you'll see what I'm talking about there. Idiomatic. So the code should feel natural. The code should feel natural to someone who's looking at it. They should say, yes, that looks like code. That looks like familiar code. That doesn't look like clever, esoteric code. That doesn't look like unfamiliar code. And the last one is domain-based. And domain-based in not just in language, not just using domain language, but in structure. And I'll describe a bit about what that means as well. Okay, so let's take a look at some of these things. Composable then, code that is easy to use gets used and used and used and used again, okay? So if you make your code easy to use, other people will use it. And this is in a number of ways. This is what it does. So your code components should be composable, but also your software itself should be composable. So what does that mean? That means that it should have a small surface area. Things with a small surface area. If it's a class, it doesn't have too many methods. If it's a method, it doesn't have too many parameters. If it's a package, it doesn't have too much going on in it. So I'm more likely to use it. And is it intention revealing? Okay, does it tell me what it does, and does it tell me what just from its name what it does, so that I can decide whether or not it's the thing for me? So badly named, if you come up with a brilliant solution to something and it's poorly named, it's not obvious what it does just from looking at the name, I'm unlikely to go scrabbling around in the code just in case it happens to scratch an itch I've got. So small surface area, intention revealing, and one that's a little bit subtle, or at least it caught me out a few times, is about dependencies. So Joe Armstrong, the late wonderful Joe Armstrong, inventor of Erlang and a huge contributor to the software community, he has this lovely quote. It's actually about object-oriented programming, this quote. He says, "You wanted a banana, but you got a whole gorilla attached to a jungle." Okay, so imagine I went in to get a banana and I got this. What did I get? I got hang on, there's a gorilla attached to the banana and there's a jungle attached to the gorilla. One of the very first open source things I wrote, which no longer exists, was about for dealing with EJBs, Enterprise Java Beans, which thankfully also practically no longer exist now. So EJBs, massively over-engineered solution to a problem that arguably we didn't have anyway, from the late 90s. And I wrote this thing that meant that you could test an EJB outside of an application container. An application container or app server was an enormously complicated thing that was the runtime environment for these complicated things and a bunch of other complicated things. Just as long as you land the word complicated with EJBs, we're on the same page. So I wanted to write these kind of test-driven, or test first. So I wrote a little thing that would basically allow you to exercise the behavior of an EJB outside of a container. I was very pleased with this. I showed this to a buddy of mine. His name's Joe Warnes. Joe Warnes appears a lot in this talk because he personifies, his code personifies Cupid to me. He's a very inspiring man. So he said to me, he said, "This is really great." He said, "Why are you using a logger?" I said, "What do you mean?" He said, "I was using log4j." He said, "Well, you've got a dependency on log4j." I said, "Yeah, that's okay." He said, "Well, the thing is, if I want to use your tool, I now have a dependency on log4j." And I was just like, "Well, everyone uses log4j, so what?" He's like, "Well, what if they don't? Or what if they do, but they're tied to a particular version, and now that means that they can't use your..." And I was just thinking, what was landing was this: is that if you've got a tool that's a testing tool, and it happens to do some logging using a logging framework that's completely orthogonal, it's completely independent to its testingness, then that is going to limit its composability. It's not nearly as useful. So now someone, in order to use my stuff, has to then make an assessment, have to make a call about whether they're going to pull in all of the rubbish that I made them pull in. When you get into the age of things like Node.js or Java package management, and you suddenly, I want to use this thing that that maybe, I don't know, it does funny line endings for me or something, or some string manipulation thing. And I suddenly find that it has like a tree of like 40 or 400 dependencies that all get pulled in, right? This is now a nightmare. It's much less composable than if it didn't have those dependencies. So composable code then, small surface area, it doesn't do much, right? What it does, it does what I need it to do, and I don't need to worry about all the other things. It's intention revealing in name and purpose, right? I can see what it does, so I can assess whether it's for me, and it doesn't have many dependencies, right? It has as few as possible. Zero is good. Zero dependencies is a lofty goal. It's a worthy goal. Okay, onwards. Unix philosophy. Okay, I'm a big fan of Unix, partly because Unix and I are about the same age. So we both started in 1969, and so I've grown up with. I haven't literally grown up with Unix. It was the first proper, like when I went to university in 1987. It was the first proper, I was going to say mainframe, certainly like connected system I ever used. So we had these literally green screen terminals, and they were connected to a Unix thing called Pyramid OS X. And so I've been using VI or Vim VI for probably over 35 years now or something. It's horrendous. Still can't quit. Still can't quit. I'm still in Vim, and no, I can. I've figured out how to get out of Vim. But Unix philosophy. So Unix has been insanely successful as an operating system because its core underlying design is very, very simple. Okay, in Unix, everything is a file. Right, that's it. Everything is a file. Memory is a file. Files are files. Directories are files. Devices are files. The network is a file. Everything's files. And so you can use a sort of file and directory kind of hierarchy model for practically anything. And also in Unix, files contain text or not text. And the ones that contain text, you can do stuff with. And the ones that contain not text, you just need to use other tools for. So the thing that made Unix, or one of the many things that made Unix so successful, is that they had a philosophy from very early on to make each program do one thing well, and only one thing. Okay, so ls, right? The ls command. I'm sure most of you have used ls to get a list of files, or to list a directory. So ls lists file details. It gives you sizes, it gives you inode numbers, it gives you age, it gives you owners, and all that kind of lots of information. Interestingly, ls doesn't know that information. It doesn't know how to get that. So there's another Unix command called stat that a lot of people don't know about. And stat is the thing that actually inspects files. So stat comes back with a structured record that says, here's everything you need to know about the file. So what ls does, it doesn't actually list files. What it does is it formats file information that stat got for it. So each program does one thing and one thing well. Interestingly, the other part of the Unix philosophy is that things should compose. Okay. However, what they didn't do was take the naming thing particularly to heart. So Unix commands have really arcane names like sed and grep and unique, but they just stopped spelling unique at Q because the 4 letters is enough for anybody or something. And some of these commands do have fantastic backstories. Grep has a great backstory. Sed has a great backstory. DD is one of my favorites. So DD stands for copy and convert, clearly. So the reason that they called the copy and convert command, it takes data off of magnetic tapes back in the dark ages when we had magnetic tapes, and it converts it. So the reason that they called the copy and convert command DD is because just down the hall, Dennis Ritchie and his buddies were working on a C compiler, and the C compiler was called CC. So that name was gone. So what are they going to call it? DD, right? This is a true story, and this shows you what you're up against with bad naming. But with composability and doing one thing well, there's practically nothing you can't do. So part of the Unix philosophy is to expect the output of every program to become the input to another. And it's interesting that they say program. It's not every utility, every Unix utility. Any program you make with those utilities, same deal, right? So expect the output of every program to become the input to another. So I can cat, and it gives me the contents of a file. Grep then looks for certain patterns within that file and shows me the lines that have those patterns. Sed is a streaming editor. That means it changes the content of those lines that I selected using grep. Sort then puts them in order, and unique then removes duplicates. Okay, and then I can do a bunch of other things. So now I can do some quite sophisticated processing, manipulation of text just by putting together these primitives. And this is very much the kind of the Unix philosophy, is make each program do one thing well. So obviously, as soon as I said this, someone said, well, hang on a minute, isn't that the same as SRP, single responsibility principle? And I maintain it isn't. So SRP is about, if you read the kind of canonical definition, if you like, it's about code having reasons to change. Code should only have one reason to change, which I don't understand that statement anyway, because all code has many reasons to change. But let's go with it. Code should have one reason to change. So that's about the code itself. I'm talking about what the code does. right? Code should only do one thing. So that's my Unix philosophy. P then is predictable. I think of predictable as a generalization, if you like, of testable. So people talk about testable code. I wanted something that was broader than that, but had the same intent. And the reason for that is this. I have worked with joyful code that had 0 tests. And the reason it was joyful is it was really obvious what it did. It was really obvious to just looking at the code, I could tell what it did. And I have the comfort and the confidence that Dick Gabriel talks about to make changes in there. One of my earliest debugging experiences, and I remember this, this is from like 1991, I think, thereabouts, right? So that is, what, 30 years ago? Good heavens. So, yeah, bunch of years. 1991, and I was working on some complex image processing software. So I was digital image processing was my first job out of college, and I was looking at someone else's complex digital image processing software. And the bug was something like, I mean, it's been a long time, but it was something like there were certain, because I did color manipulation. So you give it a color for printing. So you had CMYK, they call it, cyan, magenta, yellow, black color codes, and those are used for printing. So you'd give it CMYK values, and it would go through some kind of transformation and give you an adjusted color out. So you get another set of CMYK out. And it mostly worked, apart from some weird corner cases where it came up with the wrong values, and that was the bug. So I went into the code terrified, lots of trepidation, no idea if this is going to work, etc. And when I opened the code in my editor, and again, this is using VI in C, using the way you navigate C code in VI is with a tool called C tags. And what C tags does is it means that you can navigate through things like function calls to where the functions define, that kind of stuff. So you had some code navigation, but it was very primitive. And anyway, so I go in to look at this guy's code. And I just smiled. I remember smiling, and it was a smile. I promise you, it was a smile of utter relief. I was so worried about going into this code, and I just went, "Oh, wait, I know what this does." Right? He's written code that is so easy to understand. Even I can understand it. You know, kid fresh out of school going, "I don't understand." Oh, wait, I get this. And so then I just followed the code through to where it was doing the transformation stuff, and looked at the bug I had, and the bug was a good bug. It said, here's some inputs and outputs that don't work. Here's the expected output. And I was able to trace the bug in about less than 20 minutes, I think. I was able to identify what the bug probably was, and it was something like a greater than instead of a greater than equal, like it was a bogus comparator. And I fixed the bug, or at least I made the code change, and I built the code, and I was pretty confident that the thing I'd come up with was the right thing, and it was right. And I remember this feeling of just joy and achievement and whatever, and also thinking it wasn't my victory. Right, the victory belonged to the person who wrote that code in the first place and made it so wonderfully easy to navigate. So predictable is the characteristic of which testable is a subcategory, if you like. So predictable means it behaves as you expect. It doesn't have surprises. So Kent Beck's one of his criteria for good code, passes all tests. Absolutely. What I'm saying is that should be true even when there's no tests. Right? It should be really easy to determine that it's fine. So that's the first thing, is its behavior. The second thing is it's deterministic, right? Behaves as expected with no surprises most of the time is no good to me. It's no good to anybody. Okay, what they call Heisenbugs, which is a bug that only occurs until you observe it and then it disappears. Yeah. So it does the same thing every time. Okay. And not just behaviorally, it doesn't behave in the same way. It doesn't give me the same answers every time. It's more than that. It's that it operates in the same way every time. So I have these well understood operating characteristics, and that gives me confidence. Okay. So if, for instance, it makes a call to a network call or a database call or some service call, and I know that always happens within 20 milliseconds. It might be plus or minus a few, but I know that it's 20 milliseconds plus or minus a few. I can be confident about that code. If it's 20 milliseconds, apart from sometimes when it spikes to 2000 milliseconds, and we can't tell you when that is, suddenly imagine lots of those pieces all composed in a system. I've got a cascading massive error condition just waiting to happen. So it's deterministic. And the last thing it is observable. And this is in the technical sense. In the Charity Majors has been doing some brilliant work in this space with observability with her Honeycomb startup. Talking about observability rather than monitorability. So monitoring is a thing you have to do to a system. It's a labor-intensive thing. I've got to monitor this system. Observability is a characteristic of the system itself. And all it says is this. It says internal state can be inferred from outputs. So I can see what it's doing and maybe how frequently it's doing it. And based on just that and nothing else, I know what its internal state is like. So it's a very simple criteria to describe. It's really hard in practice to make this true. You need to design observability in from the get-go. You can't tack observability on in the same way you can't tack security on. It needs to be a front of mind consideration from the very get-go. So instrumentation, which is the ability of something to be measured, to measure itself, and telemetry, which is the ability to get that measurement at a distance. So anything tele is distance. So television is distance. Telephone is speaking at a distance or hearing at a distance. So telemetry is measuring at a distance. So on instrumentation, I want telemetry. Once I can measure at a distance, I can then observe. Once something is observable, I know huge amounts more about it than a non-observable system. And if you target observability, determinism, and behaving as expected, a lot of those other characteristics you realize are secondary. So testability is a natural consequence of those things. Okay, arguably clean architecture is a natural consequence of those things, because in order to make something deterministic and observable, I'm probably going to need to make it out of small pieces that I can reason about and compose those small pieces in ways that I can reason about. So that's predictable. Idiomatic, there is much we can say about idiomatic code. So an idiom is a way of communicating, a way of using language. The great thing about idioms is they are completely arbitrary by and large. So I'm actually speaking to the conference from, I'm on holiday in Cornwall in the southwest of England. Luckily, I'm in a caravan that has really good Wi-Fi. So hello from Cornwall. So Cornwall and Devon are neighbouring counties in the UK, and they have a word for someone who's not from round here. In one of the counties, the word is grockle. In the other county, it's an emmet. Right? Both of these are made-up words. Right? A grockle and an emmet are both made-up words. What I love about them is they both mean the same thing. So a grockle is anyone who doesn't know what a grockle is, and an emmet is anyone who doesn't know what an emmet is. And these words are completely different, and these counties border each other. So this to me is like like the perfect example of an idiom for me. It has meaning, it has local meaning, and it has universal local meaning. Everyone in Cornwall knows what an emmet is. Everyone in Devon knows what a grockle is. But it means nothing anywhere else. So what does that mean? Well, that means if I'm going to write idiomatic code, I need to know the language idioms. So what are the standard features in this language? What are the affordances it gives me, the constructs? And not just syntactically, what are the core libraries and how do they work and how do I use them? How do other people use them? And what are the kind of the standard frameworks that tend to go with this stack, or the standard tool chain that goes with this stack? The more I can conform to those things, even if I don't necessarily agree with them, the less surprising, and in terms of unpleasant surprises, the less surprising I'm going to be to other people. So it's broader than just knowing that, that Clojure, for instance, Clojure is a very small language. It's a Lisp that runs on the JVM, and it's brilliantly small language. However, I may need to run off and get power in a moment, which is really poor planning on my part. I was convinced that everything was fully charged. So Clojure is a tiny language. The thing is, the libraries, the core libraries in Clojure are brilliant. They're really, really well designed, and they cover a lot of territory, right? There's a lot of what they call power to weight, right? So the language itself is small. The core libraries are quite small, but again, they compose brilliantly. So my experience of writing Clojure, and I haven't done a lot of Clojure, but my experience generally of writing Clojure is I write what I think I'm going to write, and it's quite a lot of code. And then I find something in the core libraries, and I can delete some, and then I find something else, and I end up typically with like a handful of lines of Clojure leaning on the core libraries that I didn't know were there because I don't know the libraries well enough. And it's a very, very well designed language in that way. And so that means that your code feels natural to work with for someone who's used to working with that code. And it feels natural to work with. It goes with the grain. So as well as the language idioms, though, as well as knowing Clojure and its libraries, or knowing Java and its libraries, or knowing Python and its libraries and its ecosystem, it's about what are we doing here? What does a house style look like? Yeah. So internally, and there might not be one, right? Or it might be de facto. It might not be written down anywhere. Yeah. So write code that looks like other people's code. Sam Newman, microservices DevOps, Sam Newman. He has this lovely saying, or he said it to me a couple of times anyway. He said, it's better to be consistently wrong than inconsistently anything. So in other words, if everyone else is already doing this thing and you just think this isn't how I do it like that anyway for now, right? And then maybe bring them on a journey where we're going to do it better, differently, whatever, maybe something a bit more up to date. But that means then that you're not making anything worse, right? And it may well mean that, that doesn't mean never change anything. It means that when you change things, be very deliberate about how you're going to change them. So we might say, okay, we're moving from this style of Java to, we're going to start adopting some of the, we've got an old Java code base that's pre-streams and pre-functional affordances and single method interfaces and all of that. We're going to start bringing it into that world. Well, we're not just going to down tools and do that for the next 2 years or whatever. That's not going to help. What we can do is we can make a call. We can say all new code will be written in a modern idiomatic way rather than a classical idiomatic way, if you like. And we can also say that any code we touch, we will convert. So that means that where there's a carrying cost, right, where it's going to be a little bit more expensive to do changes while we're in that transition period because we're doing the change that we want to make and we're cleaning up the code. Arguably, we'll be able to get there faster anyway, right? So as you start cleaning up this code, you realize that the reason that these things are in the language is because it makes it easier to do stuff. And then over time, you've now just got some old legacy parts of the code base that haven't been touched in a big bunch of time. And you can make a call. You can say, we can wrap those in an interface and say, anyone, here be dragons. Or you might say, we're going to, as a chunk of work, we're going to migrate the remaining piece. So you're not stuck in time. What you are doing is you're choosing to be consistent. And this is the thing, you can only write idiomatic code if you learn the idioms. If you bother to learn the idioms and you understand how they work, and you listen to the code, and you let it guide you. And back again. I'm now on the hunt for a particular cable. I know it's around here somewhere, and I can't see it. I can now see it. Okay. So I'm going to, without anyone even noticing that I'm missing a beat in any way. Oh, I'm not going to. Okay. I may lose video in a moment. We should be fine. So you can only write idiomatic code if you learn the idioms. And then finally, domain-based. Okay. What is domain-based? So this is a couple of things. For a start, we use domain language. This is the core kind of domain-driven design construct, if you like, is that we use the language of the domain. I wrote this in 97 Things Every Programmer Should Know. My contribution, my one thing, was to code in the language of the domain. And remember that there's multiple domains. Okay, so it's not just if we're doing healthcare systems. It may be that we've got patient records as a domain, but then maybe we're storing those patient records somewhere. So we're storing them in some kind of distributed store. So there's a domain language around that distributed store. There's a domain language maybe around getting into that system and authentication and so on. So there's going to be a bunch of different domains. And The other thing, and this I've got a real bugbear about. I'm going to do a little rant here, but only a small rant. Is that I care about how you structure the code. And I think Rails is probably the biggest culprit for this. And just because it was the most popular, right? It became insanely popular in a very short amount of time. And one of the things it does is it says, we've got a place for controllers, a place for views, a place for models, a place for helpers. That's my favorite one, helpers, right? Why the hell are helpers? And so you end up with just a bunch of different directories that are named for framework constructs. And I don't want that, right? I want payments as a place where a bunch of code lives, or loans, or onboarding, or whatever the domain concept is, whatever the services that I'm building. I want that to be how my code is structured. And this isn't just a cognitive thing. I mean, it makes it easier to reason about code. It's also a structural thing in terms of then if I'm writing a build, right? Rather than saying, well, pick these things out of that folder and these things out of that folder and these things out of that folder and maybe do it by name, and I have to have a naming convention. It's all the things that have payment in or payments or something, but not the ones that have pay, because that's a separate thing. Rather than having crazy build rules like that, it's just grab everything in the payments area, in the payments folder, and build that, and that's the payments component, and grab everything in the onboarding place, and that's the onboarding component. It makes your deployment story, and then through that your operability story, much more sensible. And also it uses domain boundaries. So hats it to Simon Brown here with his lovely C4 model with his and he talks about containers and the idea that you might have components, but then the containers are the deployable unit, and you might have a number of components within a single deployed container. But those at each level of boundary, I'm using the domain boundaries for module boundaries. So in other words, each module is a subdomain in a domain-driven design sense. Okay, so my units of deployment now align with my units of domain modeling, align with my units of code structure, and there's so much less cognitive load, and things are much easier then. And finally, then, so here we are, Cupid for joyful coding. I want code that is composable, plays well with others. I want code that follows that Unix mindset, that Unix way of doing one thing well. I want it to be predictable. And if you're a TDD person, I'm a TDD person. I like me some TDD. I'm not obsessive about it. I use it where it makes sense. That's great. That's a really good tool for predictability, but that's not the whole story. It's not nearly the whole story. Idiomatic. So I want code that follows the conventions of the language, of the toolkit, of the library, of the community, of the ecosystem, and also of the organization I'm in, or the code base, or the product that I'm in. And again, you only get those by learning them, right? You can't fake idioms. And finally, domain-based. So we use domain language, obvious to me, obvious. But also, it took me a while to realize that this was an area of cognitive load, of grating, of extra mental work that I shouldn't have to do, is structure. Is if you use domain structure for that code, then you end up in a happy place. And when I see code that is these things, it makes me happy. And you can use Cupid as an overlay, as I said. So what you can do is you can look at the code you've got and you can say, is this component composable? Is this lump of code I'm looking at here composable? Could I make it more composable? Or how could I make it more composable? And I look at the next thing. How could I make it? Does it do one thing and does it do it well? Could I make it do fewer things, right? Does it do one thing and a bit of another thing, which is going to get confusing to someone who's not me? And does it do it well? Is it a comprehensive solution, or do I need to do this thing and then get a load of other stuff in? And I'm not, again, this isn't me, so I'm not suggesting to over-engineer things. It's all about trade-offs and balance. But it does mean it's doing one thing well. Predictability. How can I make this code more predictable, more observable, more testable, right? How can I do that? Idiomatic. Am I leaning on the affordances of the language and its community? And if not, what can I do? And domain-based. And all of these, when I'm looking at my own code, when I'm looking at other people's code, these are things that I realized I had been naturally applying these filters for many years anyway. And I'm super grateful to Phil Nash for making me articulate them, because I'm hoping they're useful. I'm finding them useful. So I hope you find them useful. So with that, I'm going to say thank you. And I guess I'm going to hand back to someone for some questions. So thank you very much.
Yes, thank you very much, Dan. Very nice presentation. And actually, I just realized probably this Cupid makes you fall in love with your code, right? So
yeah, you see, that's what you want. Love programming. Program with joy.
So thank you for your presentation. And I will show you your small gift, which you will get via post. So that should be
fantastic. I love these mugs. Do you know that's my second craft mug, and I still have my first one at home. It's a joyful thing. Thank you very much. I'm super grateful to the artist as well.
So enjoy really your coffee from this mug or whatever you drink. Yeah, and now it's open for questions actually. So I would like to ask the audience to put your questions into the chat. I see already you have started to use the chat functions and you started to make some socializing there. It is for the purpose of socializing and to ask from the organizers. But now you can ask from Dan. So maybe just before getting any questions online, I have one question on the back of my mind, and that is about, I mean, I'm working in a large company, you know, and the large companies also have some kind of rules on how to code, how to format. And I think it sounded very familiar with this idiomatic that you said, that certain words are used. What is your opinion on that? So is it?
So I'm a fan of the idea. I'm a fan of the idea of having a house style. It's not often, am I being mean? I was about to say it's not often that I see it done well. When it's done well, it's brilliant. So what I want is minimalist. I'm a minimalist in terms of guidelines. So what I want is fantastic. I can switch this off, and I think we're all good. Yes, fantastic. So I've seen organizations, particularly large enterprises, where they have like volumes and volumes of style guides and coding guides and whatever else. And it kind of doesn't matter how good they are. I can guarantee that only one person in the entire company has ever read them cover to cover, and that's the person who wrote them. Okay. So, and no one else, right? No one else, because it's just intimidating. It's a daunting thing to read. And so they won't. So if instead you give me the smallest amount of code as possible, the smallest amount of guidance as possible, but no less. So Go as a language. So it's no coincidence that Go is a very clean, idiomatic, beautifully documented, very well structured language. It's Nat Price, one of the JMock folks, mock objects folks. He describes Go. He says it's such an ugly language. The only thing you can do with it is work, which I think is a little harsh. But it doesn't have any fancy language features. It doesn't have higher kinded types and stuff, right? It's a job. It's a jobbing language. It's a language designed to do work with. And if you look at the documentation there, it's just brilliant, right? It's just so well done. So all of the code, so all of the documentation, the core library documentation has code examples all the way through. And all of the API designs is designed to be sort of similar to each other. So Go comes with a tool called Go Format, Go FMT, and I believe Rust has the same thing. And what Go Format does is it formats your Go source code into a house style. Right now, the house style, I'm pretty convinced the house style is designed to offend everybody. Right? There is no one who looked at that house style and said, that is a good style for code. Like they use tabs for indentation, and tabs for indentation is illegal, right? Or certainly should be illegal. But they use tabs. They put curly brackets in the wrong place, right? And officially the wrong place. But when you have multiple assignments, multiple variable assignments, they line up all the equals. So they put white space in to line up all the equals. And I'm so OCD. I love that, right? But anyway, it doesn't matter. It doesn't matter, because what that means is everyone's Go code looks the same. And there's a whole class of arguments you never have, about formatting code. So having a style guide, make it example based, right? So show me code examples so I can make my code look like your code. Don't give me Bacchus now, a BNF. No one, right? A parser can read BNF. Human beings were never designed to read BNF. BNF was never designed to be read by human beings. Give me examples, show me examples, and give me the smallest amount of advice you possibly can so that my code is likely to look similar to your code. If you can do those two things, you have a fantastic house style documentation.
I very much agree with you, actually, on all these aspects you just mentioned. There is one question from Siddharth. How can you measure if these properties are there in the code? So if some code is, let's say, written in this CUPID format.
That's a great question. How can you measure it? For me, it's there's a relativeness to it. Okay, so it's not about absolute measures. It's about comparing code to itself, to versions of itself. Well, I can look at some code and I can say, could this code, is this code composable? Could I make it more composable? What kinds of things would make it more composable? Well, let's take a look at its dependencies. Do I need all those dependencies? Could I thin out the dependency graph? That would help, right? Now, there isn't, I mean, there's probably a metric for number, well, there is, you can measure the number of dependencies, but I'm not going to say that this number is good and this number is bad. I'm going to say that fewer dependencies are always universally better than more dependencies, right? But again, even as I say absolute statements like that, it depends. It may be that you can give me a much more valuable, a much more useful component by having a couple of extra dependencies than without. So maybe you end up sort of hacking around something. Again, very early in my career, I was writing, and this is going to show you how old it was. I was writing a floppy disk loader. So the little save icon, hey you kids, the little save icon on your on all your apps is actually, it's not just a square with a corner cut off. It's a physical device that used to exist in the world. And so I was writing a floppy disk installer for Sun workstations. Sun is also a company that used to exist in the world, doesn't anymore. They invented Java. So, and I was writing a loader. So the idea is that you'd get a new blank Sun machine, a pizza box machine, and you'd put this floppy disk in and it would start to load. It was like a bootloader. So it would load itself, then it would load an operating system, and then it would load the product onto the thing. And then we ship the whole pizza box as the product. Now, it turns out there's not much that you can get on a floppy disk of Sonos, as it was then, of the operating system commands. And so we found we could get awk, the awk binary. So awk is a wonderful little programming language, massively underrated, I think, programming language. It's been a core part of Unix forever. And so we rather than having, I wanted to have WC as a word count. I wanted to count the number of words in a thing. But WC binary was too big to fit on there, along with awk. So I wrote WC, I wrote a word counter in awk as a little script and put that on the floppy disk with it, right? That's unnecessary. That's an unnecessary piece of work. I would much rather have had the dependency on WC and not had the extra work. So with a lot of these things, maybe an extra dependency is going to give us a better solution. And again, we can look at some of these other characteristics. Surface area. Yes, I can say fewer exposed methods to achieve my goal are better than more exposed methods. Fewer permutations of parameters is better than more. But that's not an absolute. It may be that there's certain use cases where having those more gives me much more power to weight. So I'm sorry, there aren't absolutes. There aren't measures. There are relative measures, though. I can talk. We should be able to, as a community, as a bunch of programmers, we should be able to all look at some code and look at a before and after picture, and we should be able to say, did that become more predictable? Did that code become more composable? Did that code become more idiomatic? And we should all, by and large, agree. That would be my goal.
Thank you for your answer. There's another question. It's from Peter, and he's asking about single level of abstraction. Where would you put that in this CUPID structure? So does it relate to the domain-based, maybe? The single level of abstraction.
Single level of abstraction. I don't really understand the question, if I'm honest. So we're saying, Are we saying that having a single level of abstraction is good? And therefore, which of these characteristics would it be in?
Yes, Peter thinks it's important.
So no, that's great. So I think let's see, single level of abstraction. Oh, I see what you mean. So you don't have big things and little things all going on at the same time. That to me, again, it's a brilliant characteristic. I'm a big fan of it. It is a natural consequence, or it should be a natural consequence of some of these CUPID properties. So, for instance, if something does one thing well, then it won't be working at multiple levels. It'll be working at the level it works at, and it will compose things that work at a lower level, right? So ls, again, the ls command, it doesn't also go into the file system and ask files about themselves. Okay, it uses stat for that. And so each of these, if it's composable and if it does one thing, then it's very unlikely to also be working at multiple levels of abstraction. Would be my snap assessment. I'd need to look at that. It's a really good question.
Thank you. And now I moved into the Q&A tab as well, and there you have a lot of questions with
I don't have the app open, so you're going to have to guide me.
So I see this one from Robert. How does your described unique philosophy of doing one thing well fit the NPM ecosystem, where every small module doing also one thing well, but feels like a new dependency? Where is the difference?
Right, and this is the thing, so if you look at NPM, it's Darwinian, and it's still at that very much that kind of Cambrian explosion of people having good ideas. And by and large, most of the developers there are, I'm going to say, yeah, I mean, there's basically, there's a power curve, as there is in any population, where most people have less than, say, 2 or 3 years experience. And then there's a chunk who have maybe 3 to 5 years experience, and then fewer. So that kind of there's a power curve going down. And so someone will write something, and leftpad was the classic example, right? Where it or the right pad or whatever. There was a padding, there's a string padding thing that just put spaces at one end or another. And this is like a CS 101 programming exercise. Write an algorithm, write a function that puts an appropriate number of pads, appropriate number of spaces to round it up to the next multiple of 8 or whatever. And so someone wrote this thing, and then they put it into NPM. And why would you do it? It's actually more code to include this thing and to write the dependency in the package JSON and to import it, and than it is to just write the line of code or the 2 lines of code function that does your padding. So there's a huge amount of, I'm going to say, unnecessary cruft in there. There's a culture of, Ivan Moore came up with this lovely phrase, postmodern programming. He says, I believe, this was about 10 years ago, so I believe that all the code we will ever need has been written. It's all out there. Programming now should just be grabbing code that's already there and banging it together. And he called this postmodern programming. Okay. And that seems to be the culture in the Node world, is if someone, if I can find something that does this 2 lines of code, it's apparently somehow better than writing the 2 lines of code. What you want in a CUPID kind of ecosystem, if you like, is some kind of curating. So NPM isn't curated in any way. It's just there, and people shove stuff in there. And you hear about things by osmosis. Yeah, you hear about things because you happen to see them in a project. And often you see them way after you implemented something else, and now the cost of undoing all that and adopting this thing is going to be really high anyway.
Then sorry to stop you. Can I just because I would like to ask 2 more questions, and we are
I need to answer them much more quickly. Okay,
so let's have a very quick answer for 2 more questions.
I apologize. I do these big rambling answers.
No problem.
So just to wrap up then, the problem with an ecosystem like NPM or any big kind of library type ecosystem, Perl has CPAN is a similar problem, is when it's not curated. And there's no kind of rating system, or there's no way of knowing which things are good, which things are supported, which things are maintained, which things have a community around them. So you end up with just this complete crapshoot. So a CUPID ecosystem will have a level of curating as well. I think that's really the point.
Then just 2 more quick questions. what do you think about solid?
I promise quick answers.
Yeah, can we just say that solid is not enough, or parts of it can be substituted instead of hopping on X is bad, Y is the way? Yeah, debates.
So it's. I'm not saying it's a bad and good thing. I'm saying it's a. I can understand the motivation for solid and those principles. They are by and large now they've served their purpose. They're no longer. I don't think they're even good advice for writing code now. So talking about substitutability, Liskov substitutability, and saying, well, subtypes and whatever should implement. Don't have subtypes, right? Don't have subtypes. Have compose things. Composability over inheritance for anything. And I know I'm mixing subtypes and subclasses. I'm doing that kind of semi-deliberately. But these principles are there. I mean, that's all I can say. They're there. They're neither useful nor not useful. They're neither necessary nor sufficient. Code with these characteristics isn't necessarily better than other code. My humble opinion is that code with CUPID properties is measurably nicer to work with than code without CUPID properties. I can't say that about solid. That's where I am with it.
Thanks for the answer. So I would like to suggest in the Q&A sessions in Hopin, there is a lot of other questions, and probably it's for a chat discussion, or even in the breakout sessions, socializing sessions. I think if you can join, then we can discuss those questions further. Unfortunately, we have to stop because the next session will start. Thank you very much once again for your very wonderful presentation.
Thank you very much. Thanks for inviting me.
So
I wish everyone a fantastic remainder of the conference.
You too.